There's Chemistry, and welcome to your Chapter 7 Types of Reactions lab. So, follow along with your procedure, and you will take excellent observations, meaning you should observe all the things that you can see with your eyeballs, and all those things should be jotted down in the appropriate section for each appropriate experiment. And then we will take all these notes together, and you guys will be able to answer a whole bunch of analysis questions and take stock of all the amazing chemistry things you know. All right, let's go. Demo number 1 says that we're supposed to have some aqueous copper chloride, but here we have solid copper 2 chloride. How do we make it aqueous? We add water, because that's what aqueous means. Yes, we have water plus solute. That solute dissolves. The resulting solution is our aqueous copper 2 chloride, right? So once we dissolve it, it is that characteristic bluish color we talked about in class. That means copper 2 ions are present. Now that we have aqueous copper 2 chloride, we will go ahead and add our piece of aluminum. And now if we observe, we'll see that, oh, it appears as though nothing is happening, but we will keep watching and we will be thorough in our observations about things like time and the things that we see. And remember, we should record all the things that we see so that way we can reconcile them with our written reaction, right, and all the things that we know. So take good observations. Here we have a candle made primarily of, oh, you know, and now we have a match, and when we light this match, we are going to expose our candle to the flame. And clearly, I think, you can tell a reaction is occurring. Take some good observations. Here we're going to get an up-close look at what's happening here. Get good observations, and we will be able to put 2 and 2 together at the end. And we'll come back and look at this candle again in a few minutes. Here is demo number 3 and the pieces of the Bunsen burner. Yep, you should know these. Here is where, so now we're going to show that, so that tubing connects to the gas, and there are gas lines that run obviously into the spool, just like it would for a stove or an outdoor grill, for example, right? Right, now to actually do the demo, here is our piece of magnesium. It is bright, it is shiny, it is, oh, what's that word for it being flat and for then being flexible? And then we're going to expose it to a flame. Now take excellent observations. Look, but don't look too brightly. It's kind of like the whole sun thing, right? And then in just a moment, make sure we've got time-related observations. Get some good observations here. Now we're going to put it in a little watch glass so you can see, and it is clearly different. Revisiting demo 1 and 2, there's the candle, new observations. There is the aluminum in the aqueous copper chloride. Note that we tapped the test tube and something happened, so take note of that. Now, just to make sure that we are observing any color changes appropriately, what we're going to do is we are now going to go ahead and put a white background against the test tube so we can sort of keep track of colors, right? Colors that might be happening in the test tube, right? Now, obviously, the type of color, we're just trying to maximize the color difference, right? So if we were forming a, I don't know, white precipitate, for example, then putting it against a black background might be more helpful than a white background, right? So here's where our, art knowledge comes into play. Now we have demo number 4. First, we're going to take some water, and it's actually an aqueous solution of sodium sulfate because there need to be some ions present in order for electricity to be conducted. So we add that water to our tub where we have 2 copper electrodes, and here we have a battery that we're going to connect some electrodes to, and we are going to then hook this battery up to those copper wires. Note that once we get that battery hooked up, ta-da! Now you should look at your reaction and ponder. Well, you should just write down your observations first, and then you can ponder the implications of them, right? And this is an example of one of the times where a reaction as written may not necessarily encompass all that is happening. Now we're going to take a test tube and we have to put some of that same solution in there so the electricity can continue to be conducted. So we'll fill it with a little bit of that solution. And you'll note when you look at the test tube, it is not full of the solution. Then we'll put it over that gas producing electrode, which means that the gas will collect, right? That's called water displacement, right? The gas will collect at the top, push the water out the bottom. Now we're going to expose it to a flame. Listen carefully. Ta-da! What was that sound? Okay, and here we have demo number 5, and that's our aqueous copper sulfate, which you should have guessed. That's our aqueous sodium chloride, and we will mix them together. And behold, your observation. Take note. Now we're going to do demo number 6. Here we have some aqueous sodium phosphate and aqueous iron 3 nitrate, and then we're going to mix them together. Behold, your observation. Take good notes so you can piece it all together with your reaction later. All right, let's go back to that candle, demo number 2, because obviously things that keep occurring should be revisited over time. So here we are, and clearly things are different than they were before, so make sure you have some good notes about what you see, and don't forget to include what you don't see that perhaps you may have anticipated seeing, right? So take good observations. This is what demo number 2 looks like several minutes later. Here is another visit to demo number 1 with the aluminum in the aqueous copper chloride. And so you'll see that it is again different as we give it more time to sit. And as we agitate the tube, we should be able to take note of a few other things. And make sure you get some good observations. You will need them later. Okay, so here we have demo number 7. That is copper to carbonate in the bottom of the test tube. Note we're using some test tube tongs to hold onto the test tube because obviously fire is hot and the glass will get hot. And note that the mouth of the test tube is pointed away from other humans because sometimes things spatter and we do not want it to spatter onto people. Now, you'll note that again, it gets waved in and out of the fire, okay, because we want it to heat, but we don't want to, say, melt the glass of my test tube, right? So we don't want it to get too hot. We just need to heat that sample. And we agitate it a little bit because we want it to heat evenly. We try to spread it out and give it maximum surface area again so it can heat evenly. I'm sure everyone has had the experience of food that looks done on the outside but is clearly not done on the inside because the heat isn't distributed very well, right? And so maximizing surface area helps to distribute the heat better, right? So we are going to heat our sample until, I said 2 minutes, but really there will be a point at which it is clear that the chemical reaction has occurred, right? And again, make sure you are taking good observations, yes? Observations means the things that we see with our eyeballs. So now it's done. I'm just trying to get some of the condensation that forms, right? In this case, the condensation is not the result of water from the reaction, right? Just the fact that you have hot and cold. Okay, reaction is done, and now part 2. We are going to grab a wooden splint, we are going to light it on fire, and then we're going to insert it into the test tube and take notes. So, let's try one more time. It happened again. I wonder if that is the observation. 3rd time for good measure. Clearly, that is the observation. Jot it down. And those are your observations for the Chapter 7 Types of Chemical Reactions lab. So now you just need to take those observations and use them, right? Those are going to be your evidence for answering the post-lab questions. So go ahead, have at it, and make sure that's complete for next period. All right, be good. Have a good day. Bye.